Hi there, Epidemics. Good afternoon. Okay, so we have some more presentations scheduled for today. Does anybody want to volunteer to go first? Jerry does. Okay, so what I'm going to do, hang on.
Professor, I'm gonna have to rejoin the call. I'm gonna have to leave and rejoin just because I'm on my phone right now and I can't give a presentation from my phone.
Okay, that's fine. Oh, do. Okay, Jerry, I've made you co-host.
So do I share content?
So, yep, there should be a black bar toward the top, well, top or bottom of the screen, and one option should be,
Yes.
Yep.
All right. Let me get to my presentation. This will stop. Do you want to continue? No, I don't want to stop it. Okay, cool. Slideshow. You can see everything?
Nope.
No?
No.
I'm sorry. Let me see how to do this. Share screen. Everything in screen including. All right, we good now?
No, still not good.
Yeah, I'm on an Apple. I don't know.
That shouldn't matter.
Right. I'm hitting share screen. It's saying I'm broadcasting. Let me stop and start again. Maybe
when you share, make sure you click the tab that says like screen one. Don't just click the individual one for the PowerPoint or whatever window it is. You got to click like the whole screen.
There you go.
Nate's always the guy. All right. Am I audible?
Yes.
All right. Hookworms. That's literally a magnified view of this worm, and that's actually its teeth. Probably the first worms I ever saw with teeth. What is a hookworm? A hookworm is an intestinal parasite that feeds on blood by attaching itself onto the intestinal wall of the host. How does one contract hookworm? If you walk around barefoot over contaminated soil, the young hookworm larvae can enter your body through the skin of your feet and cause an infection. Without a host, hookworm larvae they die 3 to 4 weeks in the soil, so they need a host to survive. How does it go from your feet to your intestines? So the hookworm larva enters your bloodstream from your foot, then it travels through your bloodstream to your lungs, and you actually cough it up. And when you cough these larvae up, you swallow them back into your intestines. So then they're sucking blood from the inside. So it's like vampirism from the inside. What are the symptoms of having hookworms? Skin rash on the feet where the larva entered your body, coughing or wheezing, abdominal pain, anemia, diarrhea, weight loss, and sometimes there are no symptoms at all. Why doesn't the immune system kill the worms? The short version is that the NETs, which is a part of your immune system, capture and destroy invading microorganisms, but hookworms secrete I don't know how to say that word. Could you help me, Professor?
Deoxyribonuclease.
That one. So the worm secretes that dioroxy, and that effectively makes your immune system ineffective. So they're inside of your body, eating you from the inside, and your immune system can't do anything about it. Sucks. How do you treat hookworms? I don't know how to say that word either. So that medication, these are a family of medications that get rid of body parasites, worms. It usually takes about 1 to 3 days for them to be treated, and your stool can be tested to see if you still have hookworms, because that's what ultimately happens. You end up pooping out the larvae of hookworms. So how does hookworm spread the dumb Southerner stigma? Because that was actually the topic question. So hookworm larvae are in soil. Southern Americans in the 20th century and back were mainly farmers. So they walked around barefoot as they were farming, and hence the larvae are in soil. So you're walking around barefoot in soil that probably has manure in it, and manure is really maybe a vector for the larvae. So you're walking around barefoot in the farms, and then they enter your foot, and that's how they get into your body. Hookworm still a prominent ailment. It hasn't been totally eradicated, but greatly reduced. Indoor plumbing and mechanized farming practices were large contributors to culling this parasite infecting humans. Basically, no one is pooping outside anymore, which is, again, the larvae are a part of the, your bowel movement. And because we're using machines to farm now, no one's walking around in the fields as much as they were 100 years ago. So indoor plumbing and machines helped eradicate hookworms. Also, the Rockefeller Foundation Sanitary Commission helped as well. He donated $1 million in 1910 to treat over 400,000 people with deworming medications. After the Rockefeller Foundation intervened, school teachers and officials of that time period and region reported that the children of their schools were testing and performing better in school. Because hookworms affect your cognitive ability, you can get nerve damage from them. They can actually go to any part of your body, but they would rather be inside of your intestines. Hookworms, tapeworms, because that's the first thing I wondered. I'm like, is this a tapeworm? But they actually aren't. Most notably, hookworms feed on your blood via blood vessels in your intestines, and tapeworms feed on the food in your intestines. So they eat what you eat, basically. They both evade being digested by the host because they have that protein covering their body that suppresses the activity of enzyme trypsin. Basically, trypsin. It just nullifies your digestive juices. Your digestive juices are not effective to them. So we can't, even though they're eating us, we can't eat them. Well, maybe if we chew them up. And that's ultimately it on hookworms. So just in short, wear shoes outside. Don't walk around barefoot. I know your mother or grandmother told you that years ago. They literally can bite through your skin and go through your blood, and you cough them up and swallow them back into your body. It's kind of an involved process, but it's pretty interesting to me. Any questions?
I had a question. Could you go back to that the last slide? A parasitic, is that nematode? Is that the word? Okay. I don't think I've heard that word since SpongeBob SquarePants. So.
Oh yeah, I know what you're talking about.
Yeah.
So it looks just like that, actually.
Any other questions for Jerry?
Good job, buddy.
Thank you, appreciate it.
Yeah, that was good. Did you come across any discussion of the idea of worm therapy?
No, I didn't. What is that? What could worm therapy even be? Wearing shoes? No.
No, actually, it's kind of the opposite. Worm therapy is the idea that some modern health conditions that involve an overactive immune system can be treated with low doses of parasitic worms.
I don't think hookworms will be efficient or applicable in this situation.
I'm pretty sure they're one of the ones that gets used.
Really? They're sucking your blood? How though? I would love to. I'll look up this later, I guess. I don't know how they would affect your immune system in a positive way.
Yeah. It's not a mainstream idea, but
I'm not doing it.
yeah, I'm not doing it either.
I saw a picture of it being in someone's eyelid, and our nerves don't heal as well as other parts of our body. So when we get nerve damage, a lot of times it's permanent.
Okay.
Let me stop sharing, I guess.
Yeah, hang on. Somebody has their hand up.
That was just me. That was
Okay.
me. So you said an overactive immune system. So like something like that would be like psoriasis. I know it's like a skin overactive immune system. Like I have psoriasis. So like how would that is like for all overactive immune systems or just like certain particular?
Can I make a guess, Professor?
Yep.
So say your immune system are soldiers and you have 100 soldiers and it's over, maybe you need 50. And then once you get to 100, it's overactivity. So if you're using 50 to fight something else, maybe it lowers the activity of your immune system. That's my short version.
Yeah, that's not the idea. It's a good guess. But the idea is that our immune systems need to be trained how much to react to things and what to react to. And the thought is that those of us in first world countries who wear shoes all the time, because we have a lower exposure to diseases and specifically to parasites, that our immune system doesn't learn to tolerate certain things. And because it doesn't have anything to do, it tends to go after a lot more things that are inappropriate, like your cells.
Oh, wow. I understand that.
Mm-hmm.
I'm
Would
not
that
using
be related to the memory cells, like how they with the innate immune response and learning how you're training your immune system through an exposure to these pathogens or okay. And then my second question was that deoxyribonuclease, that's an enzyme, right?
Yes.
ASD suffix. Okay.
Yes. Okay, great. Who else is ready to go today?
I'll go.
Okay. Who spoke up?
Juliana.
Juliana. Okay, I'm going to give you co-host permission. Ooh, syphilis. All right.
Oh, do you see it?
Yes, I can see it.
Okay. Yeah. So my project is about syphilis. I'll be talking about the stages of syphilis. I won't be touching on the Tuskegee syphilis experiment. I just feel like that's a too big of topic to get in this PowerPoint. So what is syphilis? Syphilis is a bacterial infection caused by the bacterium Treponema pallidum, I think it's pronounced. This bacteria is commonly transmitted through sex. Syphilis can be easily cured with antibiotic medicine, but if left untreated, then it can cause permanent damage. Syphilis develops in stages and symptoms can vary in each stage. After the initial affection of syphilis, the syphilis bacteria can stay dormant in your body for decades and then become active again. So syphilis is spread through skin-to-skin contact with someone who is already infected. You get it through your vulva, vagina, penis, anus, mouth that touches someone else's syphilis sores. Syphilis is not spread through casual contact. So it's not going to be spread through like sharing food, drinks, hugging, coughing, sneezing, things like that. Sitting on toilets. I was told sitting on toilets, you would get syphilis, but that is a myth. So the main way and not limited to getting syphilis is through having vaginal and anal sex. It is less common through oral sex, but it can still get contracted that way. Lots of people do not know lots of people do not know they have syphilis because the symptoms the first symptom is a sore. So sometimes they don't see the sores because it's inside of the vagina or anus. So they're not able to see it. So they don't know they have syphilis. So the first type of syphilis, like once you contract it, is called primary syphilis. And the first sign of this syphilis is a sore. And it's called a sancre. I don't know if I'm pronouncing it right. The sore appears at the spot in which the bacteria entered the body. So if you have open, so it enters the the sore will appear where the bacteria entered the body. The sore usually develops after 3 weeks of the initial exposure. Many people, like I said, do not notice the sore because it can be painless. But the first sore can heal itself within the first 3 to 6 weeks. So the secondary syphilis, within a few weeks after the first sore healing, some experience a rash that begins on the trunk or torso of the body, but eventually covers the whole body and even the palms and soles of the feet. The rash is generally not itchy and may be accompanied by like wart-like sores in the mouth or genitalia area. Some people experience hair loss, muscle aches, fever, sore throat, swollen lymph nodes. These signs and symptoms may disappear within the first few weeks or repeatedly come and go for up to a year. And this is the second stage of syphilis. Then there's latent syphilis. If you're not treated for it during the first stage or the second stage, it will enter the stage of being latent. In this stage, the disease moves to the secondary stage into a hidden or latent period when you have no symptoms. And this can last for years. And you may not know that you have it. So the next one is tertiary syphilis, and this is about 15 to 30% of people infected with syphilis don't get treatment and develop complications known as tertiary syphilis. In the late stages, this disease may cause the damage of brain, nerves, eyes, heart, blood vessels, liver, bone, and joints. Then if like untreated for a while, this syphilis can, travel to neurosyphilis at any stage of the disease. It can travel to neurosyphilis and spread among other damage it can cause to the brain, eyes, and nervous system. So congenital syphilis is syphilis that is given to a baby from a mother. So babies born from a woman who's infected with syphilis or may not even know, the mother doesn't even know she has syphilis, can pass through the disease through the placenta or during the act of birth. Most newborns with congenital syphilis don't have symptoms, although some of them may have a rash on the palms of the hands or soles of the feet. Later signs and symptoms may cause deafness, tooth deformities, saddle nose, which is basically where the bridge of your nose is like collapsed. Babies born with syphilis may be born too early as well and may be possible die as well from it. So these are just a few pictures of what it can look like. I also, I didn't know what it looked like, but it is just a very, if you see this first picture, it is just a very small sore and it can be very unnoticeable. Yeah, and then it comes and then after the stage 2, it comes in this body rash on the, the trunk, the palms of the hands, soles of the feet. And then the third one is more like your organs and things like that. And here's just another of the chancre, and then your mouth. Yeah, it's pretty crazy stuff. And these are my works cited. I did have a 1-minute video from the Mayo Clinic. I don't know if you want to watch it or not, but it's a pretty summing up of the whole thing.
Okay.
Syphilis is a sexually transmitted infection caused by the bacterium Treponema pallidum. Dr. Stacy Rizza, an infectious diseases specialist at Mayo Clinic, says syphilis affects men and women and can present in various stages.
Primary syphilis causes an ulcer, and this sometimes isn't noticed because it's painless and can be inside the vagina or on the cervix. After a few weeks, 2 months, they can get secondary syphilis, which is a rash.
It may then progress to latent stage syphilis, and finally, the most serious stage, tertiary. Pregnant women are not immune to syphilis. Congenital syphilis can lead to miscarriage, stillbirth, or infant deaths. That's why all pregnant women should be screened. Syphilis is preventable and treatable. As for prevention, Dr. Rizza recommends barrier protection during sex.
And that's during oral sex, anal sex, vaginal sex, using condoms, dental dams, and any other barrier protection.
For the Mayo Clinic News Network, I'm Vivian Williams.
So, yeah, that's it.
Okay. Great.
I have to stop and tell you.
How do you stop share? Oh, right here. Sorry.
Here we go. Okay, thanks, Juliana. Does anybody have questions? Nate, go ahead.
You may have covered this, or I just was wondering, At what point is syphilis untreatable? And yeah, I guess that's really the crux of my question.
Yeah, that's a good question. So based off of like what I read, it looks that it can be treatable like mostly at all stages, unless like if you have like neurosyphilis or tertiary syphilis, which is like the third stage of it. But it looks like in the first and second stage, it can be treated. But it looks like if you don't catch it in the first or second stage, you don't know that you even have it because it can go latent and dormant.
And I guess to follow up on that, if the treatment is in the second stage compared to the first stage, is there irreparable damage that would occur in between that you wouldn't be able to rectify, I guess you could say?
I'm guessing yes, because it seems like it's a disease that like not similar to HIV, but like it like the longer it's in your body, the worse. Well, you can't get rid of HIV, but the longer it's in your body, it seems like it wreaks havoc on your system, your organs, your brain. Yeah, so
Yeah, that makes sense. Thank you.
of course.
And you did a great job.
Oh, thank you.
Yeah, I'm gonna add to that. If there is neurological damage, that is permanent, but that's going to be stage 3 syphilis. Liver damage, depending on how much there is, the liver can recover from some liver damage, but not a lot. So it's really going to depend on how much damage has been done. Jerry, go ahead.
So when the sores cover your body, is it contagious then? Like your skin contagious at that point?
I would guess yes, because it's kind of what I've read. It's like the sores, like when you
Wow.
are contracting it, it's the sores that are giving it to the other person.
It reminded me of smallpox, that picture we had. I was like, whoa.
Yeah, and the pustules, you can't touch the pustules. Yeah, that's what it reminded me of too, as well.
But great job. That was excellent.
Thank you.
Yep, good job. Any other questions? Okay, syphilis is one of those reasons why if you are sexually active, you should visit a doctor regularly just to make sure you don't have these STIs. Especially syphilis can be treated easy. Gonorrhea and chlamydia can be treated, but if you don't treat them, then you can have long-term consequences. It's also why condoms are very important. Okay, anybody else going today?
Yeah, I'm going.
Great. Let me make you a co-host. Oops, hang on.
Oh wait, I was gonna say I also want to go today.
Okay. Let me make Mike the co-host first. Mike, you are up. Mike, you're muted. But we can see your screen.
You want to click the slideshow tab, and then it should have like a start slideshow option.
Okay, thank you. So I'm doing yellow fever. Yellow fever is a virus. It's has RNA. Its flavorous family, which is West Nile virus, is connected to it. Mosquitoes are the only ones that spread it. And it's like HIV in the sense that they don't know, but they predict that monkeys started it. So then they have this transmission thing where originally, I guess, the jungle cycle, mosquitoes are biting monkeys, and then apparently some human came by, got bit, so went to intermediate stage. So the human got it, and they became infected. Then a mosquito bought them, and then hit somebody else, and then they went to the home, and then it just spread like crazy. And then yellow fever. Oh, mosquito. It lives in tropic and subtropic areas. It feeds during the day, so you got to be careful. And it also spreads to other areas too. But it starts in Africa. Yellow fever. Oh, that's a picture of the mosquito there. Yeah, so it's Africa and South Africa, but it can travel. So so global warming is a big problem because as the warmer it gets, the more they can travel. Especially with planes, they get on the plane with other people. That's how they travel. And right now, not many U.S. citizens are likely to get yellow fever because it's not really here. Yellow fever, about 200,000 cases and about 30 deaths. In severe cases, you could die within 7-10 days. And yellow fever, it takes like 3 days to 6, but the World Health said it could take maybe a week too. So you might get home and not know, and then a week later. And you have fever, pain, aches. That's like the mild. People get that, but then so it could take like a week or a month or even longer to recover because it affects your liver and other things. And then this is the sad part about it is some people they get it and then they feel great, and then all of a sudden it comes back really bad. It could be like an hour, a day, a week, or something like that. Then it comes back and they get yellow face, yellow eyes, and then the liver is like destroyed, the organs, and they're bleeding. That's internal bleeding. And how is yellow diagnosed? They have blood tests, and the patient has signs or symptoms, and then patient history. This is why it's good to tell your doctor where you're from, because there's a TV show that they always end up finding out that the person had like some disease from other country, and once they tell them and they find it. And but also the other problem too is they always look for malaria, so they sometimes think that's what it is. How is yellow fever prevented? Or get vaccinated. Use insect repellent, wear heavy clothes, and then a mosquito bed. And to get vaccinated, it can last a whole lifetime, but not in all cases. People can get a shot at age 9 months. And most people just need it once. It's the same as when you get the disease too. Usually you just get it once. So, and then some people shouldn't get vaccinated, which they have certain allergies like eggs, chicken proteins, immune system problems like AIDS. That's part of the reason why there's a lot of it, because they can't get the vaccine. And then pregnant women and nursing mothers. How is yellow treated? There's no treatment. All you can do is deal with the effects, like the high fever, the liver issues, internal bleeding. So you basically got to see a doctor. I mean, go to emergency room and be watched for a long time. And then in conclusion, if you travel to South Africa or that areas down, you should get vaccinated. And also tell your doctor when you get back that where you're from, so they can figure out if you get something later on. And then here's my sources.
Great. Thanks, Mike. Does anybody have questions for Michael?
I kind of wanted to just add to it. I know it's in the flavivirus family, but when I lived in Japan, we had to get vaccinated against Japanese encephalitis. So yeah, I mean, there's so many different, I think Dang is also in that viral family too. So
Mhm.
Yep.
Yep.
So they're preventative measures, but not measures that can be done after post-infection.
No, nothing yet.
Wow.
Yeah.
Go ahead. So, sorry, Professor.
If you are traveling internationally and you are traveling from an area that has a yellow fever outbreak, you have to have what's called a yellow card that shows that you've been vaccinated for yellow fever. So if you're trying to go from, let's say there's an outbreak in Brazil and you're coming back to the US from Brazil, you can't come into the US from Brazil unless you have that vaccine. So they can be really, really picky about that because we don't want to spread here. The Aedes aegypti mosquito is becoming more widespread. It's becoming an invasive species. Juliana, go ahead.
Oh, I just wanted to confirm. So it is from a specific type of mosquito. It's not just any old mosquito.
Yeah.
Okay.
Yes, it's the Aedes aegypti, which can spread several different diseases.
Is that mosquito a vector for malaria as well?
Malaria is Anopheles. It's a different group of mosquitoes. Yeah. All right. Thanks, Michael. Good job there. All right. I heard somebody else speak up that they were ready to go. Was that you, Stephen?
Yeah, it was.
Okay. Let me. You are now a co-host and we are ready to go.
How do I screen share?
Either at the top or bottom of your screen, there should be a black bar with little icons, one of which says share screen.
Wait, could you repeat that? Sorry.
Yeah. Do you see a black bar either at the top or bottom of your screen
On Zoom?
with a bunch of, yeah, on Zoom with a bunch of icons?
Yeah.
Right in the, well, it's in the middle on mine. There
Oh, I
should-
see it. I see it.
There you go.
Okay. Here it is. Are you guys seeing it?
Yes.
Yes.
Okay. So mine's about cholera. So this is the first page about cholera. Cholera is a bacterial illness that is contracted through consumption of contaminated food or water. It is caused by the bacteria known as Vibrio cholera, infecting the small intestine. The bacteria in the fecal matter of an infected person has the possibility to contaminate water supplies and also food sources if not disposed of properly. The incubation period is commonly 1 to 2 days, and it usually takes 12 hours to 5 days for someone to start showing symptoms after ingesting contaminated water or food. Accidental consumption of contaminated water or food could then further the spread of the illness if it's not isolated properly, which is why you got to use like latrines and you need to dispose of, your waste properly. The means of which the illness is spread is the main reason why cholera is mainly seen in underdeveloped countries and was also much more common over 100 years ago before we had modern plumbing. Excuse me. Cholera diagnosis. Diagnosing cholera requires a stool sample from the sick individual. in order to identify presence of the bacteria, but symptoms include profuse diarrhea, vomiting, fatigue, dry skin, dehydration, and cramping. The most recognizable symptom is the rice water stool type, which is watery, mucousy diarrhea, which has a yellowish appearance. Cholera is fatal if it's not treated as soon as possible. The diarrhea it causes the host leads to severe and rapid depletion of electrolytes, which is the main factor that leads to cholera-related deaths. How to protect yourself. Cholera prevention methods mainly entail mitigating environmental factors by using safe, uncontaminated water sources for things such as drinking, brushing teeth, washing hands, or food, or showering. Another important measure to take is to wash your hands often and to make sure that any contaminated fecal matter doesn't get near the drinking supply. Again, we don't really have to worry about this because we live in a first world country, but in other countries, they don't have the same luxuries as us. This is the most important measure to take because cholera is very unlikely to be spread from one person to another, and it must be spread through contaminated water or food. The immediate sources of infection are also stools and vomit from carriers. Cholera treatment and risk factors. Without treatment, cholera is fatal, which is why it was able to claim so many lives before modern medicine. Treatment options only include rehydration, IV fluids, and antibiotics. Risk factors include being a child or elderly, having low stomach acid levels, having poor sanitation, or having the O blood type. Children are 10 times more susceptible than adults, and people with the O blood type are more susceptible because the toxin in cholera hyperactivates a key signaling molecule in the intestine of blood O type individual, which causes them to excrete electrolytes profusely through the form of diarrhea. Prevalence and key numbers. Every year, cholera kills anywhere from 21,000 to 143,000 people, mainly in Africa, India, and Latin America. And it infects around 2.9 billion more, or billion, no, not billion, million. In the 1800s and 1900s was when cholera was at its most prevalent. Between 1817 and 1917, it's estimated to have killed around 40 million people in Asia, mainly India and Russia. There were 4 cholera pandemics throughout this time, 2 of which were in Russia and the other 2 were in India. Conclusion, cholera is an extremely virulent and contagious illness that will almost certainly kill anyone infected by it if left untreated. It has contributed to tens of millions of deaths in the past couple hundred years, and this is the work cited. I cited these wrong, but I'll fix that. And that's it.
Okay. Thanks, Stephen. Anybody have questions about cholera? Jerry, go ahead.
What's a comment? First 2, Love in the Time of Cholera is a good movie. You guys should watch it. 2, man, indoor employment changed a lot with the world because hookworms and cholera were pretty much culled a bit because we weren't pooping on the floor. So cheers to that.
Yeah.
Juliana, I see your hand went up.
Yeah, I was gonna ask. So basically, you essentially like you have like you basically die from like dehydration, like your body's not able to
Yeah.
absorb the water.
Yeah, essentially, because when you have diarrhea, you're basically just excreting water and electrolytes from your body. And when you lose electrolytes, what happens is your brain loses the ability to communicate with the muscles, and eventually you'll just die.
Oh wow.
Nate, go ahead.
What is the modern treatment today? Well, I guess that was redundant, but what's the modern treatment for cholera?
Basically, all we have is, where is it? All we have is like rehydration, and I'm looking for the
I'm guessing like some of that Pedialyte, right?
Yeah, IV fluids
Yeah.
and antibiotics too. Here it is.
Okay. Oh, yeah. I must have missed that. Great job, though, by the way. Very
Thank you.
informative. Very cool.
Thank you.
So I have a question too. I know that cholera is more common when there's a lot of flooding. Is it a concern in parts of the United States with the increased rate and severity of things like hurricanes due to climate change?
I haven't seen anything about that. It's a lot less common. It's like extremely uncommon in North America, just because in places where cholera is present, it kind of creates like this feedback loop, I guess, where like one person gets cholera and then it somehow gets into the water supply and just like it spreads so profusely. But since in North America we don't really have cholera in the first place, it's hard. It's very hard for us to have that risk, even in places with increased flooding and stuff like
Great.
that.
Thank you. Okay.
I just have one more question.
Yes.
So does the water have to be, this may sound like stupid, but does the water have to be ingested, or can you just like wash your hands with infected water and like not touch your face and it just like sit on top of you and it not infect you and eventually die off? Or like
It has to somehow, the bacteria has to somehow find its way to your small intestine. So if you go swimming in like cholera infected water, you might not be drinking any of it, but somehow it's, it's probably going to find its way into your body. Even if you're not like drinking any of it intentionally. But it's like it's not only like a risk if you're drinking the water, like if you shower in like cholera infested water, then you're probably gonna get infected as well.
Yeah, any cholera that's on your hand, if you touch your mouth, it's good. There's a chance you're gonna get infected.
Yeah.
Or if you if you eat a sandwich for lunch and you haven't washed your hands.
Also, I forgot to elaborate on this point, but if there's like if there's wildlife inside of an infected source of water, like fish, for example, and then you eat the fish, then that also has the potential to infect you with cholera.
is that like raw fish? Sorry, is that like raw fish or is that like cooked fish? Can you like cook the cholera out? I don't know.
I think I'm not sure actually. I think eating raw fish is more risky, but I think you can like cook the cholera out.
Interesting.
Okay, great. Thank you. Was there anybody else who wanted to go today? All right, you guys have just rocked. I mean, these have all been fantastic presentations.
I just looked it up to confirm, and yeah, you can cook the cholera out of food because it kills the bacteria, but it's still
Good.
risky.
Thank you.
Okay. So if you haven't done a presentation, if you're doing a written project, those are due Sunday before midnight. I mentioned there's a short reading and a short video I want you to watch, but that's it for this week. And now it's time to get back to antibiotics. So you've probably heard that Alexander Fleming discovered penicillin in 1928. Hopefully, one of the things that you've picked up this semester is that a lot of these stories that we have aren't always exactly accurate. We lose some of the complexity when we tell stories over and over again. And this is one of those. You've probably heard the story about Fleming leaving a petri dish with bacteria on it on his lab bench when he went on vacation. And some mold spores came in, landed on the petri dish, and killed off the bacteria. This sounds good, but we don't think it's true. So, Nate, go ahead.
Just a comment. It's always when these scientists go on vacation, isn't it? Like with the who was it? What's his name's assistant left out the
Yes, was that Pasteur? Pasteur's assistant, I think. Yeah. I think that means we all need to go on vacation more.
Soon, very soon.
So there are a couple of problems with this story. The first of which is, penicillin inhibits bacteria growth. If the mold that makes penicillin landed on a petri dish that already had bacteria on it, the bacteria would not die off. It wouldn't be able to kill the bacteria. It inhibits the growth. So you can see that really clearly on this slide. We have our mold here that makes penicillin, and somebody tried to put Staphylococcus bacteria on it, and it wasn't able to grow in this area. Nice, clear results here. So that's problem number one. Problem number two is that it's long been known, well before Fleming did his work, that moldy bread could be useful for various ailments. So people would put moldy bread on infected wounds. Sometimes they would eat moldy bread for things like urinary tract infections, digestive problems. And these worked. Nobody knew why they worked, but they worked because they had the right kind of mold. You can't just use any mold, and it doesn't work on every bacteria, but it did work a lot of the time. And this was common practice in ancient Egypt, China, Serbia, Greece, Rome, pre-Columbian Central America, probably Africa, probably most of the world figured this out at some point. Now, once we figured out how to extract the penicillin from the right kind of mold, that obviously works better than just using moldy bread. Now, here's the third part of the problem. In the 1800s, researchers already knew that bacteria would not grow on plates that had mold. So decades before Fleming discovered penicillin, it was already pretty widely known. And a couple of the researchers actually identified a strain of mold and published this information. So while going from knowing that a specific strain of mold inhibits bacteria growth to using it as a medication, that is a leap. And that's an important development. Yeah. It's exaggerated that Fleming discovered penicillin. Okay, so screenshot if you want it. Nate, go ahead.
So is it correct in saying that it like other, I guess you talked about antibiotics earlier and how they attacked cell walls and prevented protein synthesis. That's kind of like the core strength of penicillin as well.
Yes.
So it prevents them
Penicillin
from, oh, sorry, I'm sorry. I didn't mean to interject.
Yeah.
You can finish that thought.
Penicillin specifically blocks cell wall manufacturing and cell wall repair. So it really inhibits growth of bacteria more than killing bacteria.
So I guess by preventing the bacteria from multiplying, it would give the body a better fighting chance at defeat. So, okay, so it's more of like a utility. It's not like, because I had this preconceived notion that they killed the bacteria, like they just instantly destroyed it. But from what I'm comprehending is that they prevent it from further manufacturing, therefore allowing the body's immune system to fight it and be much stronger against it.
Yes.
Is it accurate? Okay.
Most antibiotics work that way, yes. That's why we call some of them bacteriostatic. That's what that word means. But before there was penicillin, there were what were called the sulfa drugs. These are antibiotics. These were developed or discovered in the 1920s and 1930s. There was a synthetic dye that contained sulfur, and it was discovered that this could treat bacterial infections. This specific drug, this sulfa drug, reduced reduced death due to childbirth infections from 25% to 5%. So 25% of women who got an infection during childbirth would die from it without treatment. But if they got treated with the sulfa drug, the survival rate went up and only about 5% would die from childbirth infections.
Did they ingest this? Like, was it liquid or pill?
I think, yeah, it was ingested. So people would either take a pill or take it in a liquid form. Yes. Now, there was a small problem with this drug, and that was that the synthetic dye was already off patent. Nobody owned the right to be the only company that made that particular compound. And it was very easy to make, which is good. But because it was off patent, it was largely unregulated. And at this time point in the US, most medications were not regulated. What happens when we don't regulate drugs?
dangerous. We get knockout. We get versions that are not healthy for you.
Yep. So one company, huh?
Snake oil.
Yes, thank you,
Well,
snake
Remember they
oil.
had the cocaine eye drops back in the day?
Yeah, yeah.
Back in your day, Jerry, or what are we talking
Okay, so one company made a sweet tasting syrup containing the sulfa drug. And they launched it in October of 1937. Wow. I'm really having trouble with the typing this morning. Now, here's the problem. The sweet part came from diethylene glycol. Anybody know what diethylene glycol is?
It's antifreeze, ain't it?
Yes.
Yeah.
We use it nowadays for antifreeze. It tastes good and it can kill you.
Is there another name for it? Propylene glycol too? Or I know like there's a couple different ones. And I know they put a bitterant in it too. There was this, I was watching the forensic files. This lady poisoned 2 of her husbands with antifreeze and she got away with it, but they found like crystallized, I forget what it was, but in his liver, and that's how they found it.
Yeah, there's a lot of different things that have glycol as part of it. Not all of them are fatal. So yeah, propylene glycol, I don't remember if that one's harmful or not. So fortunately, we already had the FDA. They didn't have a lot of power, but they stopped manufacturing and tracked down most of the supply. So we don't have any information if anybody actually took this and died from it. It's possible, but the company got sued, but they couldn't get sued for putting antifreeze in it because that wasn't illegal at the time. They got sued for mislabeling. They called it an elixir. And elixirs had to have alcohol. And this solution did not have alcohol in it. So they really got sued on a technicality. If they'd labeled it a syrup, there would be no legal recourse. Would have been no legal recourse. So as a result of this, because of this incident, in 1938, the federal government passed the Food, Drug, and Cosmetic Act, which added huge amounts of regulations to the drug manufacturing process and a lot of oversight into how drugs were manufactured. So it really changed things and made it harder for snake oil salesmen. Now, antibiotic resistance started to show up to sulfa drugs very, very quickly. Anytime an antibiotic is readily available to the public, you get antibiotic resistance showing up quickly. All right, screenshot. Now, the sulfa drugs worked great until resistance started showing up. And then, penicillin was like the next target. And once Fleming said, look, we've got this mold, it can produce an antibiotic, it still took until the 1940s till people were given penicillin, because it was hard to grow enough mold and extract that penicillin in order to be able to use it on people. The first person to receive it was in the early 1940s. A police officer, I think I mentioned this, got an infection from a rose thorn scratch. So he got scratched while working in his rose garden. It got infected. He developed a raging fever, widespread pustules all over his body, and he was in the process of dying. So they treated with penicillin. They had no idea what dose they needed. That brought down his fever, but they used the entire available supply of penicillin, and it wasn't enough. And he ended up dying because he got scratched by a rose bush. The first person to be successfully treated with penicillin didn't happen until 1947. This is Ann Miller on the left here. She had a miscarriage and she developed septicemia. Septicemia is a bacterial infection in the blood. It's still pretty hard to treat. Her doctor was able to get hold of 5.5 grams of penicillin, which was half the world's supply. Doctors guessed at the dosage. She survived the night. She survived the next day. She survived the next 57 years. She's the first person whose life was saved by penicillin.
I've seen her before. This is a very famous picture, I presume.
Yeah, it's around a lot. I didn't find who this guy was. Juliana.
Also,
Yeah.
oh, go ahead.
No, I was gonna say-
Sorry, let me finish. I apologize. Did she get the whole 5.5 grams at once, or was it dosed through days?
I don't have that detail.
Cheers. And one more time, why was it only so little? People just didn't, it cost too much money to produce more?
It was very, very hard to extract and purify.
Okay, all right, thank you.
Okay, Juliana, go ahead.
Oh no, I was just gonna say, like, since you said they guessed on the dosage, like, what can you like overdose on penicillin? Is that like could she have died like from that?
Well, there's two problems. One is some people are allergic to penicillin.
Yeah, and like amoxicillin. Like, I'm allergic to amoxicillin. I don't know.
Yep. So if you have an allergy to amoxicillin and you get amoxicillin, it has the potential to kill you. Nowadays, doctors are much better about knowing that sort of information. We really didn't understand that information back in the 1940s. So if she had been allergic, it would have killed her. Can you overdose? That's a great segue to the next topic. So take a screenshot real quick, guys. And I'll tell you why too much of a good thing is not always a good thing. Reason number one The microbiome. You guys heard this term before?
Yeah, we covered it. I just don't remember what it means.
Okay, so the microbiome is all microscopic life on and inside your body. There are trillions of microorganisms of thousands of species. Your body is an ecosystem. It's not just you. Anytime, any medication that kills bacteria can harm the microbiome. Nate, go ahead.
Is that due to the bacteria fungal balance?
Yes, part of it is that there's a bacteria fungal balance that can be disrupted, but also because they help regulate the immune system. They help fight off pathogenic bacteria. And in our digestive tract, they produce nutrients that we cannot make ourselves and cannot get directly from our food. A lot of the B vitamins and vitamin K in specifically, they have to be modified or manufactured by the bacteria in our digestive tract in order for us to get them. As well as certain amino acids and certain fatty acids, which are used to make lipids or fats. So if you killed off your entire microbiome, that would be lethal. If you completely sterilized the human body, it would not survive. Okay, screenshot. So between the 1960s to the 2000s, all new antibiotics were variations on pre-existing antibiotics. So improving on penicillin, modifying penicillin, that sort of thing. And they all go after the same targets. So we don't, up until 2000, we weren't really getting a lot of new options for antibiotics. And bacteria are becoming resistant. So I've used this term before. What do I mean when I say bacteria are becoming resistant?
The antibiotics are not having the intended effect. Maybe the bacteria mutating or doing some more elusive tactics, or like with the hookworm, secreting some liquid or protein to counteract NETs?
Yep.
Is
We're going
that
to talk about,
plasmid transference?
yes,
Yeah.
yes.
We talked about this before.
Good, good. So it should be familiar.
That's right. Even how it can transfer those plasmids from dead bacteria too, right?
Yes,
Yeah.
yes,
3PD
absolutely. Good. Okay, so the early discovered antibiotics were what we call the low-hanging fruit. What does that mean?
Right in front of us, pretty much.
Yep. It's the ones that are easy. And now we're having to go and look for different targets and more expensive targets to go after. And pharmaceutical companies, we know they're about the profit. Antibiotics are used short term, which means there's going to be less return on investment. So there's not a lot of motivation for pharmaceutical companies to develop new antibiotics. Nate, go ahead.
How do you think we counter that? Because I think that also ties into the 6-year proprietary rule with generics. Like, you know how if a company, yeah. So
Ah,
I don't want to steer too far off course here.
yeah, that's getting into economics and government issues. I would like to see governments, require pharmaceutical companies to work on things that are less profitable. But then that steps on free market capitalism.
Well, I'm of that latter mindset, but I think there has to be an exception when it comes to medications and the pharmaceutical company, I am like a free market, like venture ideological person, but I mean, we're talking about something much different here. So this isn't like trading a stock or a 401k. This is medicine that saves people's lives. So
Yep. Okay, so we're out of time again. Oof. We are so close to the end of the semester. So I've got a little bit more to talk about with antibiotic resistance. And I've also want to talk about long-term effects after you've had an infection. Things like long COVID, post-Lyme syndrome, and that sort of stuff. So got a lot still to go, but we're almost done. One more week. I can't believe it. I'm going to miss you guys. All right. Everybody have a good weekend, and I will see you on Tuesday.
Bye, thank you.
Thank you.
Bye.
good job on the projects, guys. All of them were awesome. And y'all have a good weekend.
You too. Thank you.